So I work a lot outside because it's quieter and better for my mental health and for many other reasons. But there's a lot of people that are on the go or have a variety of reasons that they have to use hotspots or other connections. And it also is a bigger deal in places that do not have Wi-Fi, that are still developing, that they use their cell phones much more for communications and other technologies like that. And beyond all that being true, we have it. Beyond all that being true, it's just a nice, convenient thing to have. But there's a lot of problems with hotspot technology and stuff. Mainly, it can use up a ton of power for some reason. And beyond using a ton of power, it can sometimes glitch on and off. And all this can be really inconvenient if you're traveling and don't have a good power source. Or it's just wasteful electricity. So I want to go over some ways that I thought about that maybe can help get rid of this problem. So one problem is that it just updates too frequently. If we could have a computer that says that it's not connected to a power supply or that you're using a hotspot, and when it's doing this, updates less frequently with these apps online, it would save a lot of power. And you first might think, oh, that's because it's updating half the amount of time, so it's sending out signal half the time. Well, no, not exactly true. That is a big part of it, but a bigger part could potentially get from its ability to compress data better. Now, I'm going to explain to you a little bit about compression, but you don't need to understand any math for this. Compression, if it's lossless, works by finding a pattern. So here I have an example. AB is the first line, and if I say that pattern occurs one time, that AB occurs one time, it's like 1AB. My compression actually made it take out more space because I have to say 1AB. Now, and if I say AB twice, AB, AB, I can compress it as 2AB. So now I only wrote three things. I save the time and space. If I say AB three times, AB, 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 I can say 3AB. Now I've saved almost half the amount of space. If I say AB, 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 AB 4 times, I say 4AB times, and I save even a fourth of space. This means that if a computer or other device waits a little while before sending out a signal, you could potentially send half the signal or less just by waiting a longer period of time. Now, one way of doing this would be to have the computer and stuff store more or have the computer store more the basic things so it can operate long periods of time without it, and it only does it periodically. For example, if you have a Google Doc, having Google Docs, the complete software almost on your computer, saved, and it only needs to update every now and then when it thinks, hey, you're going to move to another device. Or you could even have a feature that it never updates, and it's just like Word, except when you hit a certain thing, only then does it connect to the internet. If you want to have the maximum thing, like say an email, you could, and then you could also have a version that you could even make it changeable, that you could free up space or delete space on a computer depending on how much of you want it on your laptop, depending on how much power you want to use your depending on where it uses up the most power, where you use the most power from your laptop, or when you send it out, depending on your hotspot connection and stuff, and how your Wi-Fi is using up power. Or you could have it for different uses. If you're collaborating something, you have it update more. Or if you don't have as much storage space on it, so you could, theoretically, if you had adjustment, they could say you have more or less an online feature, and maybe even one that has a little auto detect. Then you could also, with predictive programming, you could even figure out better things like, hey, maybe update this. It's not important for let's say you have something that it's, let's say instead you have something like, I'm going to give us a newsfeed articles or something, or Tinder, which is a Tinder example, but they give you a bunch of photos and stuff. Maybe only updating it, maybe waiting to update it and send out all the information until it's night when you're not using it. Therefore, it doesn't hurt the user experience, but then you also download a bunch of things so you can use it for most of the day without it having to update as much. So you could use smart programming like that, where it learns when to you're busy or not, so it can download a bunch of stuff when you're not busy and don't notice it as much. So that's the basic ideas with updating compression. Another benefit of compressing more data, also compressing more data becomes more energy efficient to extent because you can notice these patterns are bigger overall, and you don't have to run the compression again and again on little bits of data. So the compression algorithm themselves become more energy efficient, even though you're using energy more from your computer and device instead of the hotspot and transmitting it. Another advantage of waiting to compress is when you compress later on, more patterns emerge. And when more patterns emerge, you can design a better compression algorithm. And not only can you design a better compression algorithm, you can design one that's more reliable, that more times compresses it. Like here I said AB compresses, but if it was A, might have to add a thing here that's just an extra A or comma or something like that. Note that this has an extra A. But when you have fancier ones, it's more like that's not as a big deal, because if I add just a second A symbol, last A symbol to all these other ones where it's AB, repeat AB, then all these ones will only have to modify a little bit, and still you get mainly the big compression. But now you only get compression after 4. I added the symbol comma A for the last little bit. So only after like 4 do you really get a compression. 4 AB repeats. So you start, it becomes more reliable. Another idea I could have for this whole thing is you could start using encoding stuff with more zeros instead of ones, because zeros are oftentimes encoded by having no signal, while ones are encoded by having a signal, which makes sense. But zeros, because they're not transmitting a signal, uses up a lot less power. Now if you switch now binary is composed of 1 and zeros, and that's how all these computer codes work. But if you switch all the ones with zeros and vice versa, maybe you could save power that way. And something I forgot to mention with the previous ones is that when you wait to compress more data, you can detect mistakes better actually in the data transmission, because you have more data to look upon and see that something doesn't make sense because it doesn't fit with the rest of the data. And then that would be leads to better error detection throughout the system. When you have more data you're sending, it also gives you to more design choices. And by more design choices, what I really do mean is that you can figure out, hey, let's only send the most, let's update more often, or let's update less often. Or you can play around with features more about updates with more compression or compression types and stuff like that for very specific scenarios. It becomes more, you can have more in-betweens with hotspots and stuff, different levels of compression, stuff like that. Do you spend hours compressing data or just 1 minute compressing data? That's a lot more you can choose if you have a lot more data. If you have just AB, it's going to take the same amount of time, and it's not different levels of compressing. You can't compress as much as half of one. Another thing you could do to save power better is a separate idea is you can first have a lower power first option, see where it's making mistakes or if it doesn't go good, and then move to a higher power version. And again, compressing can help with this by making the data stream quicker, so you can more fast detect if there's a problem, and sending out more data, you're more likely to see if there's a problem. Another thing you could do is you can mix your data with other streams of data to more efficiently send it with less power usage. And it's because they're all being delivered together. And also, in some cases, even if this doesn't work, this could also in some cases just lead to better, less mistakes being transmitted in your data, and maybe sometimes faster coverage, because if it can detect mistakes faster, and if they're sending less data by compressing stuff, when the data is received, it can repeat the data over and over again. It has another chance to repeat it, or it can repeat it twice if it's half the amount of data and find these mistakes. And you can work on all these other extra features to detect mistakes. Other ideas I have that are totally separate would be on electronic devices having the back be a solar panel or a piezoelectric generator. Piezoelectric generates stuff from pressure vibrations. They're not that efficient compared to a lot of other energy, but I'm just talking about something slightly extended life. Or the back of something being a solar panel. You could combine them, but it'll make it a lot heavier. And generally, you can make very thin, not heavy solar cells, but the problem with them is they're not as efficient. The gaps are changing and becoming more efficient. But that could be good. And also, developing solar panels for the back of electronic devices would be its own thing, because solar panels operating in different sunlight conditions have different optimals. If a solar panel is operating in dark shade, it's different than a solar panel operating in a very bright light, because in very bright light you have to worry about heat and stuff like that can disrupt it, or there can be too much energy flowing through the system that stops working as well. It's like if you have too many electrons flowing, they more easily can flow in the wrong direction sometimes, or short circuit or decay it or wear and tear. But on the other hand, you also don't have to worry about the flow being not fast enough to capture the energy. And in a dark condition, you have a lot more worry about it not being fast enough to capture the energy, or it's just not being sensitive enough. If I was to try and make a comparison, is if electrons are flowing on if you have a bunch of electrons flowing slowly, then you have to worry a ton about friction and stuff like that, like in ice skating, when you have to make everything very conductive. But it doesn't matter. But if you have it moving very fast, then the small things then there can be chaos, where if two electrons hit each other, there's a giant explosion and it bounce off in random directions. So you have to force them more to be orderly and stuff like that. Like a crowd of people, controlling one or two person with directions is pretty easy. Controlling 5 million people in a crowded stadium is a lot harder. It's a totally different field. And not only that, is the light exposure might be different, because someone might be exposed more to indoor light, outdoor light, or various other types of light. So you really can't make the same comparisons with light. And it'll be interesting to see how well people can optimize it for different conditions. A piezoelectric device, again, is not the most efficient, but you could use it for accelerometers and other motion sensors within the device, or even microphone sensors in the device, which might be useful. There was a person trying to hook up a bunch of size accelerometers and phones to better detect earthquakes and stuff like that. Because each of them have a lot of noise, but maybe a whole giant network. Another idea would be to install more booster towers everywhere. And having more booster towers means that each signal could be a lot weaker, and therefore you would have to use less energy to make it. Another idea would be to have a quick replacement for all the batteries in the things, so you would make a more modular phone where the batteries are not always in it. You can just quickly take it out, have one charging on the side or something. Oh yes, I forgot, also foldable panels. An idea I've been having for a while is a phone that's possibly foldable, or a computer or something, so you can have the screen compact and make the screen bigger when you want to show people more stuff, or if you need a bigger keyboard because not good at moving your fingers precisely, or something like that, or another disability like that, or you don't have as good eyesight, or just want to display it to more people, or for productivity. But if you have foldable panels, that could also mean more solar panels for sunlight capturing. Another idea I have that's kind of the opposite of the quick replace with batteries is to have a local energy storage system. And by that, what I mean by that is, imagine capacitors and stuff. Capacitors do not store electricity in as high a density as batteries. They can't do that. But capacitors are alternative batteries, but they can store energy, but be made a lot smaller than batteries, and they can give off the energy they have stored a lot faster. And they can also handle a lot more charges and discharges a lot more efficiently. They have almost an infinite lifespan, and they don't heat up as much. But they just can't just store as much power. That's the biggest drawback. And the thing about them is that if you have a bunch of them located for a circuit board, you might be able to power the circuit board better and make them use less power, because A, you have more power stored in the circuit board, but B, you can have it give out the energy locally, and that means there's less energy loss throughout the whole entire circuit. It doesn't have to travel from A to B to C to D to E, F, G. You can travel from A to F. Just go directly to F. And you don't have to predict how much power the whole circuit uses and end up wasting electricity because the whole circuit wasn't using that amount of electricity. You can just more locally predict how much electricity is, which means you can save electricity because you don't overdo it as much. Then, besides that, another thing is capacitors can actually be used a little bit in computation, but that will be a very hard thing to design. Also, different electronics need different smooth electrical properties. Some of them, electricity doesn't flow exactly evenly. The voltage slightly fluctuates, the current, it slightly goes up and down, sometimes more than other ones. So if you had capacitors are used to smooth this out, but you can have capacitors in different places that are smoothing out different amounts, and we don't smooth out as much when you don't need to, which would save power that would go you lose when smoothing it out. Well, thank you for listening to all these ideas and me just blobbing. I hope you find this interesting. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. Thank you very much again. Goodbye.